Hello, and welcome to Boring History for Sleep. Consider for a moment the last time you stood at a condiment station in a fast food restaurant. You likely reached for a pump, pressed down, and with a gentle, satisfying resistance, a perfect, uniform portion of ketchup or mustard appeared. It is an action so commonplace, so utterly ingrained in the modern dining experience, that it is effectively invisible. Yet, that simple pump represents a quiet culmination of 4 decades of intense industrial design, material science, and economic pressure. It is a small machine born from the relentless pursuit of speed, consistency, and above all, control. To truly understand this quiet marvel of engineering, we must travel back to a time before its existence, to the very origins of the quick-service food industry, and explore the subtle evolution of this ubiquitous device. Our journey begins not with the pump itself, but with the problem it was designed to solve. In the years following the Second World War, and accelerating into the 1950s and early 1960s, America was undergoing a profound transformation. The rise of the automobile, the development of the interstate highway system, and the growth of suburban communities created a new kind of consumer, mobile, time-conscious, and hungry for convenience. This was the fertile ground from which the quick-service restaurant, or QSR, industry sprouted. Chains like McDonald's, Burger King, and countless regional competitors began to dot the landscape, all built on a revolutionary principle: standardization. Every burger, every fry, every shake should taste exactly the same, whether purchased in California or in Maine. This was the science of the assembly line applied to food preparation. In this highly controlled environment, condiments presented a persistent and vexing variable. In the earliest days, the methods for dispensing ketchup, mustard, and relish were chaotic and inefficient. The most common tool was a simple spoon or ladle, resting in a large, open crock or stainless steel pan. A line worker, in the heat of a lunch rush, would have to stop assembling a sandwich, grab the spoon, scoop out a dollop of condiment, and attempt to apply it with some semblance of neatness and consistency. The process was fraught with issues. It was slow, interrupting the carefully choreographed rhythm of the food assembly line. It was messy, leading to drips and spills on the prep counter, on the burger wrappers, and on employee uniforms. Hygiene was a constant concern, with open containers exposed to the air and the potential for cross-contamination. Most critically, however, this method offered absolutely no portion control. One employee might apply a generous, heaping spoonful of ketchup, while another, more frugal or hurried, might apply only a thin smear. This inconsistency directly impacted the restaurant's core promise of a standardized product. A customer might get a perfectly balanced burger one day and an overly sauced, soggy mess the next. Beyond the customer experience, this lack of control had a direct and significant impact on the restaurant's bottom line. Condiments, while seemingly inexpensive, represent a major operational cost when multiplied by thousands of transactions per day. Every extra gram of ketchup given away for free was a tiny cut into the restaurant's razor-thin profit margins. The industry, obsessed with efficiency and cost-cutting, desperately needed a better way. An early alternative to the ladle was the simple squeeze bottle. These were typically made of flexible polyethylene plastic and offered a slight improvement in speed and tidiness. An employee could grab the bottle and apply the condiment with a single motion. However, they only partially solved the problem. Portion control remained almost entirely subjective, reliant on the pressure applied and the duration of the squeeze. A new employee might apply far too much, while a seasoned veteran might apply the correct amount through muscle memory. But this was not the kind of reliable, systematic control the industry demanded. Furthermore, refilling these bottles was a time-consuming and messy task, often performed at the end of a long shift by tired employees, leading to more spills and waste. The bottles themselves were also difficult to clean thoroughly, with residue often clinging to the inside walls and cap threads, posing potential hygiene risks. It was against this backdrop of inefficiency, waste, and inconsistency that the first rudimentary condiment pumps began to appear in the early 1960s. These were not the sleek plastic devices we know today, but were often robust, mechanical contraptions made primarily of stainless steel. Companies like Server Products, founded in 1949, and Prince Castle, which had a long history of innovation in the restaurant equipment space, were among the pioneers. Their initial designs were focused on a single primary goal: dispensing a liquid from a large container in a quick and repeatable motion. The basic mechanics of these early pumps were straightforward, borrowing principles from industrial fluid pumps. A vertical cylinder, or pump body, was submerged in the condiment held in a deep stainless steel well or jar. Inside this cylinder was a piston attached to a long rod, which extended upwards and connected to a palm-depressed knob or head. When an operator pushed down on the head, the piston would travel down the cylinder, forcing the condiment trapped below it out through a spout or nozzle. A spring, coiled around the piston rod, would then return the piston to its starting position, creating a vacuum that drew a new volume of condiment into the cylinder from the well below, ready for the next dispense. A simple one-way valve, often a small stainless steel ball bearing known as a check valve, sat at the bottom of the cylinder, preventing the condiment from flowing back out into the main reservoir as the piston rose. These early pumps were a significant leap forward. They dramatically increased the speed of the assembly line. A single, swift press was much faster than fumbling with a spoon or a squeeze bottle cap. They were also inherently tidier, with a directed nozzle, minimizing drips and spills. The enclosed nature of the pump mechanism, drawing from a covered well, also offered a modest improvement in hygiene over the open crock. However, the first generation of these pumps still had significant limitations, particularly in the realm of precise portion control. The amount dispensed was largely a function of the fixed volume of the pump cylinder. If the cylinder was designed to hold 1 fluid ounce, it dispensed 1 fluid ounce. There was little to no room for adjustment. This became a problem as restaurant chains began to meticulously analyze their food costs and menu construction. Perhaps their standard hamburger only required a half ounce of ketchup, while their larger deluxe sandwich needed a full ounce. Using the same pump for both applications meant either manually performing a half pump, an inexact and unreliable technique, or using a full pump and wasting half of the product. The need for adjustability became the primary engineering challenge that would define the evolution of the condiment pump throughout the late 1960s and into the 1970s. The response from manufacturers was the development of rudimentary portion control mechanisms. One of the earliest and most common methods was the use of a simple metal collar or spacer. This was a small, removable ring that could be clipped or threaded onto the piston rod just below the pump head. When the collar was in place, it physically prevented the piston from completing its full downward stroke. For example, a collar might be designed to stop the piston at the halfway point, thus dispensing only half the cylinder's volume, a half ounce instead of a full ounce. To change the portion, an employee would need to disassemble the pump head, remove or add the collar, and then reassemble it. While this offered a new level of control, it was still a cumbersome process. It required tools, time, and a certain degree of mechanical aptitude. It was not something that could be done quickly during a busy service. As the 1970s dawned, the pressures on the fast food industry intensified. The oil crisis of 1973 led to soaring inflation and increased costs for everything from beef to paper wrappers to the petroleum-based plastics used in packaging. Food cost management became less of a best practice and more of a survival strategy. The demand for even more precise, flexible, and easy-to-use portion control systems grew louder. This decade would become the golden age of condiment pump innovation. Engineers at companies like Server Products and Tomlinson Industries began to refine the collar system. Instead of simple, fixed-size collars, they developed gauging collars. These were often thicker pieces of plastic or metal with a set screw. An operator could loosen the screw, slide the collar up or down the piston rod to the desired position, and then tighten the screw to lock it in place. Markings or indentations were often added to the rod to indicate common portion sizes, such as a quarter ounce, a half ounce, or a full ounce. This was a significant improvement, allowing for a range of portion sizes from a single pump without needing a collection of separate spacer rings. The set screw, however, was still a small, easily lost component, and the process still required a tool, typically a small Allen wrench or screwdriver, which could also be easily misplaced in a busy kitchen. Concurrent with the evolution of the collar system was a focus on the internal mechanics of the pump itself. Designers began to experiment with adjustable piston strokes built directly into the pump head assembly. One common design involved a threaded mechanism within the pump head. By twisting the knob at the top, an operator could raise or lower the resting position of the piston rod, effectively changing the length of its downward travel and, therefore, the volume of condiment dispensed. This was a more elegant and integrated solution. It eliminated the need for loose parts like collars and screws. However, these early threaded systems could be prone to wear and tear, and the threads could become clogged with dried condiment, making them difficult to adjust. The materials used in pump construction also began to change dramatically during this period. While stainless steel remained the material of choice for components that came into direct contact with food due to its durability and non-reactive properties, plastics started to play a much larger role. The development of new, more robust polymers like polypropylene and high-density polyethylene offered several advantages. Plastics were significantly cheaper to manufacture, especially through injection molding, which allowed for the creation of complex shapes with high precision at a low per-unit cost. Plastic components were also lighter than their steel counterparts, making the pumps easier to handle and ship. Furthermore, plastics were more resistant to the corrosive effects of acidic condiments like ketchup, mustard, and relish. While high-grade stainless steel is very corrosion-resistant, lower-grade steel or improperly maintained steel could eventually show signs of pitting or rust, especially around welds and seams. Plastic components eliminated this risk entirely. The pump heads, collars, and sometimes even the entire outer housing began to be made of durable, impact-resistant plastic. This also allowed for color coding. A restaurant could now use a red-headed pump for ketchup, a yellow one for mustard, and a green one for relish, reducing the chance of an employee placing the wrong pump into a condiment well and creating a contaminated, unappealing mixture. This era also saw a great deal of focus on the nozzle, the final point of contact between the pump and the food. The design of the nozzle was far from an afterthought. It was a critical component that influenced the application, appearance, and perceived value of the condiment. For smooth, viscous liquids like ketchup and mustard, a simple, round orifice was typically sufficient. It produced a clean, consistent bead of product. The diameter of this orifice was carefully calculated. Too small, and it would require excessive pressure to dispense, potentially causing the pump to spray or spit the condiment. Too large, and it could lead to a messy, uncontrolled glob of product and make precise application difficult. For chunkier condiments like relish or tartar sauce, which contained solid particulates like pickles, onions, or capers, a simple round nozzle was unworkable. It would clog constantly, bringing the assembly line to a halt while an employee tried to clear the obstruction. The solution was the development of specialized nozzles. The most iconic of these is the star or fin nozzle, often used for relish. This design featured several radiating slots instead of a single round hole. This increased the total surface area of the opening, allowing small solid pieces to pass through without causing a blockage. It also had the added aesthetic benefit of dispensing the relish in a decorative, fluted pattern, which many marketing departments believed made the product look more appealing. For thick sauces like tartar sauce or cheese sauce, a wider, sometimes flattened, or fishtail nozzle was developed. This allowed the thick product to be dispensed in a wide, even ribbon, ensuring better coverage on a fish fillet or a plate of nachos with a single pump. The internal fluid dynamics of the pump were also being refined. The check valve at the base of the pump, which allowed the condiment to enter the cylinder but not escape back into the reservoir, was a point of focus. In early designs, this was often just a loose stainless steel ball bearing that would be sucked up against the intake hole by the vacuum of the rising piston. While simple and effective for thin liquids, this system could be less reliable with thicker or chunkier condiments. A piece of pickle relish could become lodged between the ball and its seat, preventing a proper seal and causing the pump to lose its prime. meaning it would fail to draw up new product on the upstroke. To combat this, some designs incorporated larger, heavier balls or shifted to a flapper-style valve made of a flexible material like silicone, which could create a better seal around small particulates. By the end of the 1970s, the condiment pump had matured from a simple dispenser into a sophisticated, adjustable, and material-specific piece of food service equipment. A typical high-end pump from this era would feature a combination of stainless steel and polypropylene parts, an external gauging collar or an integrated twist-to-adjust head for portion control, and a selection of interchangeable nozzles for different products. The science of portion control had arrived. The 1980s ushered in a new era for the fast food industry, characterized by intense competition and a new focus on the customer experience. One of the most significant trends of this decade was the rise of the self-service condiment bar. Previously, all condiments were applied by employees behind the counter, but as a way to increase speed of service, reduce labor costs, and offer customers a sense of customization and value, many chains began moving condiment dispensing to the front of the house. This shift had a profound impact on pump design. Pumps that were once operated exclusively by trained kitchen staff now had to be simple, intuitive, and durable enough for use by the general public, including children and the elderly. The field of ergonomics, the science of designing for human use, became critically important. The shape of the pump head was reconsidered. Instead of a simple, small knob, designs began to feature larger, more comfortable palm rests or T-handles that could be operated easily with one hand. The amount of force required to depress the plunger, known as the actuation force, was carefully calibrated. It needed to be low enough for anyone to use without difficulty, but with enough resistance to feel controlled and prevent accidental dispensing. The internal spring tension was a key factor here, and it had to be balanced against the viscosity of the condiment being pumped. A thick cheese sauce would require a stiffer spring to ensure the piston returned properly, but this would also increase the actuation force. Durability became a paramount concern. A pump behind the counter might be used a few hundred times a day by a trained employee. A pump on a public condiment island could be subjected to thousands of uses, and often abuses, by customers. They would be pushed too hard, pulled up, twisted, and bumped by trays. This necessitated a move towards even more robust materials. Pump heads were often made from high-impact ABS plastic, the same kind of durable material used in car bumpers and protective headgear. Stainless steel components were often made from a thicker gauge of steel to resist bending and denting. The entire assembly had to be designed to withstand a much higher cycle count, the total number of pumps it could perform before a component failed. Manufacturers would subject their designs to rigorous life cycle testing on automated rigs that would depress the pump tens or even hundreds of thousands of times to identify weak points. The self-service environment also created new challenges for hygiene and maintenance. With customers, rather than employees, operating the pumps, the risk of spills and drips was much higher. This led to the integration of pumps into larger, all-in-one countertop units. These units, typically made of heavy-gauge stainless steel, would feature recessed wells to hold the condiment containers and a surrounding drip trough to catch any spills. This made the entire station much easier to wipe down and keep clean. These integrated stations also began to incorporate other features. For certain condiments, temperature control was essential. Chili and cheese sauce needed to be kept hot to maintain a desirable consistency and for food safety. This led to the development of heated condiment stations, with electric heating elements and thermostats built into the unit to keep the condiment wells at a precise, constant temperature. Conversely, dairy-based condiments like tartar sauce or creamy dressings required refrigeration, leading to the design of chilled units that used either ice packs or small refrigeration coils. The modularity of these systems was key. A restaurant might need a 4-pump station with 2 heated wells for cheese and chili, and 2 ambient wells for ketchup and mustard. The manufacturers designed their systems so that these different components could be easily configured to meet the specific needs of the restaurant's menu. The pumps themselves were designed for quick and easy disassembly for cleaning. In a busy restaurant, the condiment station had to be cleaned multiple times a day. A well-designed pump could be taken apart without any tools. The head would unscrew, the piston and spring would lift out, and the intake tube would detach. Each piece could then be washed, sanitized, and reassembled in a matter of minutes. This tool-free design was a critical innovation, as it made proper cleaning far more likely to be performed correctly and regularly by busy staff. The internal mechanisms continued to be refined for public use. The check valve system, for example, was improved to prevent a common problem on condiment bars: pump suck back. This occurs when a customer pushes the pump down and then releases it very quickly. The rapid upstroke of the piston can create such a strong vacuum that it not only draws condiment up from the reservoir, but also sucks air and potentially drips of old condiment back into the nozzle. This is both unsightly and unhygienic. To prevent this, engineers developed more sophisticated valve systems and sometimes incorporated a small air vent or bleed in the pump head, which would allow the pressure to equalize more slowly, preventing the violent suck-back effect. By the end of the 1980s, the condiment station was a common and expected feature of the American fast food landscape. The pumps at its heart were no longer simple mechanical devices, but highly engineered systems designed for ergonomic comfort, extreme durability, and foolproof operation by an untrained public. The focus had shifted from pure portion control in the kitchen to a holistic system of delivery, presentation, and maintenance in the dining room. The final decade of our period, the 1990s, saw the culmination of many of these trends, with a particular emphasis on two key areas: the challenge of dispensing an ever-widening variety of specialty sauces, and a renewed, almost obsessive focus on food safety and hygiene. The fast food menu of the 1990s was far more complex than that of the 1960s. To differentiate themselves in a saturated market, chains introduced a constant stream of new and limited-time menu items, and these often came with unique, signature sauces. There were smoky barbecue sauces with bits of onion, creamy southwestern sauces with pieces of pepper and corn, and tangy salsas with chunks of tomato and jalapeno. These new, non-homogeneous sauces presented a significant challenge for existing pump technology. The standard pumps, which were designed for smooth ketchup or chunky but relatively uniform relish, would clog instantly when faced with a thick, particulate-heavy barbecue sauce. The small intake holes, the tight tolerance between the piston and the cylinder, and the narrow nozzle orifices were simply not designed to handle these complex new products. This spurred a new wave of innovation in pump design, focused specifically on large particulate dispensing. The solution required a complete rethinking of the pump's internal architecture. The intake tube at the bottom of the pump had to be much wider. The check valve system had to be redesigned, often moving away from a simple ball and seat to a larger, more robust flapper valve that could easily allow chunks of onion or pepper to pass through. The piston and cylinder assembly had to be engineered with looser tolerances to prevent particulates from getting caught and jamming the mechanism. Most importantly, the nozzles had to be completely re-envisioned. A simple round or star-shaped nozzle would be useless. Instead, manufacturers developed wide-mouth nozzles, sometimes with a flexible silicone duckbill valve at the tip. This type of valve would remain sealed until pressure was applied, at which point it would open wide to allow the chunky sauce to pass through, and then seal itself shut again, preventing drips. This era also saw the rise of a revolutionary change in how condiments were supplied to restaurants, a change that would profoundly impact pump design and hygiene. This was the shift from open, reusable condiment wells to closed, sealed, disposable packaging systems. For decades, condiments like ketchup arrived at the restaurant in large cans or jugs. An employee would open the can, pour the contents into the stainless steel well of the condiment dispenser, and then place the pump into the well. This process, known as decanting, exposed the product to the air, to potential airborne contaminants, and to any bacteria present on the lip of the can or the hands of the employee. It also left a heel of product in the original can that was difficult to scrape out, leading to waste. The new solution was the bag-in-box, or flexible pouch system. In this system, the condiment was sealed at the factory in a sterile, collapsible plastic bag, often holding 1.5 gallons or more. This bag was then placed inside a cardboard box for shipping and support. The bag had a special plastic fitment or spout. To use it, a restaurant employee would simply open the box, pull out the fitment, and connect it directly to a specially designed pump. The pump's intake tube would pierce a membrane on the fitment, creating a sealed, closed loop from the bag to the nozzle. This was a transformative innovation in food safety. At no point was the condiment ever exposed to the outside environment until the moment it was dispensed onto a customer's food. This dramatically reduced the risk of contamination and spoilage. It also had significant operational benefits. It eliminated the messy and time-consuming process of decanting. When the bag was empty, the employee would simply disconnect the pump, discard the empty bag and box, and connect the pump to a new one. The collapsible nature of the bag also meant that virtually 100% of the product could be evacuated, drastically reducing food waste compared to the old can and scrape method. This shift required an entirely new generation of pumps. These pumps were designed to mate perfectly with the specific fitments on the condiment bags. Different source manufacturers, like Heinz or Hunt's, might use slightly different proprietary fitments, meaning that pump manufacturers like Server or Prince Castle had to design pumps or adapters for each system. The pumps themselves were often simplified, as they no longer needed to be submerged in a deep well. They became top-down pumps, drawing the product upwards from the bag below. The materials of these pumps also evolved. With the risk of direct contamination inside the pump greatly reduced by the sealed system, some manufacturers began to design pumps that were themselves disposable or limited use. While the main pump head and mechanism might be a durable, reusable component, the intake tube and valve assembly, the parts that came into contact with the food, could be a single, disposable piece that would be thrown away with the empty condiment bag. This ensured that a perfectly clean and sterile fluid path was used with every new bag of product, taking hygiene to an unprecedented level. By the year 2000, the fast food condiment pump bore little resemblance to its crude, all-metal ancestors from 1960. It had become a highly specialized piece of technology, a silent workhorse of the modern restaurant. A top-of-the-line pump from this period was likely part of an integrated sealed system. Its body and head were molded from high-impact, color-coded ABS or polypropylene plastic, designed for ergonomic comfort and tool-free disassembly. Its portion control was precise, likely adjusted by a calibrated ring or a twist of the head, allowing for dispense volumes to be set in fractions of an ounce. Its internal engine, comprised of a precisely engineered piston, a stainless steel spring, and a specialized check valve, was designed for a specific viscosity and particulate content. It connected not to an open pan, but to a sealed, disposable pouch via a proprietary fitment, ensuring a closed loop of hygiene from the factory to the consumer. The journey from a simple ladle in a crock to this sophisticated dispensing system is a microcosm of the evolution of the fast food industry itself. It is a story driven by the relentless pursuit of consistency, efficiency, cost control, and safety. Every design change, from the shape of a nozzle to the material of a piston, was a direct response to a specific operational challenge or economic pressure. The subtle curve of a pump handle, the satisfyingly smooth resistance of the plunger, the perfect, repeatable portion of sauce it delivers. These are the tangible results of 40 years of quiet, incremental, and deeply pragmatic innovation. It is an object so successful in its design that it has become invisible, a humble yet essential component in the vast, complex machine of modern convenience. And as you drift now into a comfortable state of rest, you can appreciate the immense amount of thought, engineering, and history that is contained within that simple, mundane, and utterly perfected device.